Fingers crossed.
Yeah. Okay, I'm also checking the event now on LinkedIn. It seems to be working. So if you're ready, Slavik, I will leave the stage to you and wish you a happy few minutes with the people here.
Thank you. All right, let's start with the some introduction presentation. Well, basically, welcome everyone attending this webinar. My name is Sławek. I'm a C++ and robotics programmer working for Spirosoft, and as a group, we are partners of Open Source Robotic Alliance, as working in the areas of different robotics using ROS and ROS2. And today's topic will be about the challenges of testing ROS2 nodes, how tests are typically written, and how we can make them more robust and reliable. I'll share some insights into common pitfalls, why traditional approaches often fall short, and finally, how our recently published framework called RTest can help you write better, more maintainable tests for your ROS2 applications. So maybe let's start by looking at some real-world problem that you may have probably encountered while implementing ROS2 nodes. The example scenario is virtually a combination of a node with two subscriptions. It processes an input coming from two different topics sent by two different nodes. So in terms of timing, you can depict it as something like that. So we have messages coming in with different frequencies published on two different topics. And we had a node that executes callbacks whenever the message arrives, and it handles it, do some computations. At least in theory, this looks linear. If we use single-threaded executor, we are guaranteed that the execution of callbacks will be done in a one after another fashion. But if we look closely at the whole stack, that's not really going to be that way. And we'll show and we'll see that testing such scenario can be actually challenging, because let's imagine that one publisher publishes with 100 hertz frequency, and the other publishes twice less with 50 hertz frequency. In real life, those numbers won't be that round and equal. You'll probably get something like 99.9 hertz. And after time, the pattern of arrival of the messages will slightly drift. And for your application to test different arrival scenarios, you have to test all possibilities and do it for very strict timing. So that will be the challenge. An example, real life scenario can be sensor fusion, when we have a couple sensors publishing data from, for example, for the wheel odometry and IMU data. Can be command filter or something like that. The actual algorithm doesn't really matter. What we are going to focus on is how do we pick the samples that are going to be fed into the algorithm. That's the first step we need to take care in order to test the algorithm later. So what actually we have to test in this example? Some basics that the node that is on the test have created the desired subscriptions for the odometry and IMU data, that the fact that it created a publisher on which it will publish some calculation results, merely the calculation result based on the received data, but we need to do it for all possible message arrivals order, like as mentioned previously, and even for very tiny time slices. So in a typical approach, we would probably make some helper entities, like additional publishers used to publish a test data, which will be then consumed by the node on the test. So like odometry and IME data. We'll probably make a subscription on the topic that is a expected output. Then, of course, create the node on the task and send some messages on those two tested topics. Then we need to make it actually run and involve the ROS execution model. So one way or another, we're going to spin the nodes and finally receive the result on the TF topic in that example and verify it. What can possibly go wrong with that approach? It's a simple example, but we're going to see that it's not actually easy to test. We have to consider the layered structure of the actual message passing path. So in between, we're going to have client libraries, the middleware, and finally some middleware implementation, which will actually take care of transporting the messages from one node to another. And on top of that, we have to also think of the time delivery and time measurement, which will be the system time in the default scenario. If we look even closer and trace the whole path of the message, it gets even worse. We don't need to go into such details for the moment. Just bear in mind that we have a couple points here, like down to the DDS processing. We have a processing loop, which involves additional threads. Then we have sending and receiving, which involves some I/O operations from the operating system and operating system scheduler. Then we have waiting for events in the middleware. And finally, in our CLCPP, we have execution model, where the order of events is also somewhat defined. And if we care about testing different event order, we have to basically consider that fact. And finally, we got the callback dispatched in the subscription. Now, let's do that example and try to run it. So let's switch to the code editor, please. And let's try to implement a basic test like we mentioned. So we are set on the middleware test. And first of all, let's take a quick look at the subscriber implementation in C++, just to grasp the idea what's going on here. So we have one publisher, which is an output. It's a topic. It's a TF topic. We are going to publish very simple data, just floating point values, nothing.
Slavik, sorry to interrupt
just an example. Yes.
Sorry to interrupt you for a second. Can you go back 2 or 3 minutes, because there was either a connection issue on your side or on mine with the live streaming, and something got interrupted for a second.
All right. So when did we actually finish?
Can you maybe start from when we switched to the VS Code, please?
VS Code.
Just make sure nothing was lost in translation.
All right.
Thank you. And sorry.
Last thing I was explaining was the complexity of the inter-process communication, the whole path that the message has to take from publisher to subscription callback. And now we switch to VS Code to do an real example, try to write a unit test for the subscriber implementation that we got here. So very simply, we have one publisher, which we want to test upon the correct result. It's going to publish very simple floating point values. Nothing real life. It's not a real sensor fusion. It's just for testing purposes. And yeah, 2 subscribers. But notice one thing. We have some kind of asymmetry here. We have 2 subscriptions for the odometry and data, and I decided for a reason that the odometry subscription will do nothing but store the last received message. And oh, I have a typo here. And nothing really else happens here. Then the other subscriptions will actually trigger some computation and publishing of the result. This will matter next when we test it, because we need to test whether not only that something happens and the result of that, also that nothing has happened in case of an event. And the computation is also very simple. It's just calculation of the mean value of the 2 last messages received. So 1 + 1 / 2. Nothing fancy, we publish. So that's the subscriber. And let's try to write some unit tests for that. So in typical, well, basically, first of all, we have to start by instantiating some kind of node on the test. Then we need to think about the execution and actually pushing the messages forward. For that, we need to think of how we're gonna spin the runtime of ROS2 middleware. And also to exchange the messages, we are going to need a helper node that will create the additional auxiliary subscription and publishers. So let's start with adding the helper nodes. Yeah, it's going to carry a publisher. Let's make it all public just for simplicity. Yeah. Then we need the other publisher that will publish the IMU data. And finally, also the subscription on which we will receive the computation result we want to check, verify. And we also need somehow to tell whether we actually received something. So maybe we can store the last results in a kind of vector. We can check how many of them have been produced and pick one for the verification. So that's a basic idea. Yeah, then let's also construct such a node. We need to give it a name, and the name will do its job. And yeah, let's create first the odometry publisher on the topic that we're interested in. The same for the IMU data. And finally, the position, well, the TF transformation subscription. Naming doesn't really matter. The only thing we will want to do is to intercept the result message published by the node under test, which will be stored then in a helper vector. So that's basically it. I think for the helper node, that will do the job. Yeah, let's add it to our test. It's like that. And now for the execution part. We're going to use single-threaded executor for simplicity, but not only. Also, we want to induce the linear behavior, not to have any race conditions. Yeah, let's add both the nodes here. And we can start, I think we can start testing. So first thing to check was whether the node on the test creating the expected entities, expected publisher and expected subscriptions. So for that, we can use actually the helper node, which subscribes to the position, and use the publisher account to check if the other node has actually published something. And the same we do for the IMU and odometry data. Just the opposite, we check the subscription count instead of publishers. That already should give us the first results. Let's try to build it, check if nothing is wrong with the code. And I will run it directly, not using the ROS2 command line options, just to show you the raw output from the Google test. And so far, so good. We just checked the first part that we were interested in. Now let's go further and do some message publishing. Let's prepare a sample message. Okay, this is going to be, sorry for that. Yeah. Let's start with the odometry message. Why we start with the odometry? Well, we want to test that nothing happens right here. So let's send a message, and once we send it, now what? How can we tell whether the other node has actually received it, but it didn't trigger any action? So visually, maybe if you have an idea how or experience how do you test such situations, just drop some comments. But for now, let's just omit that part and go further and test it implicitly. We are just going to try to trigger the other subscription. And for that, we need another test data. So we are going to send two values, 1 to 2 and 2 to 2. So we expect that the mean value is published. It's going to be 1 plus 2, 3, divided by 2, so 1.5 f. And now we need to somehow, well, this is actually, that will not work yet because we need to make the ROS execution spinning somehow. And we can't just write the executor spin because we really need to make sure that the messages arrives, and we need to check that before we go further with the test. So we probably need yet another helper, this time some kind of function that will tell us the messages were actually pushed through. So some kind of wait for data function where we are going to do something like this. We need an executor, which will be spinning. Let's define some timeout, after which, if nothing happens, the test is considered failed. And just an arbitrary predicate, which will check our condition if it's met. This is the RCL CPP clock. Store the start time of the procedure. Check whether the timeout has happened, and if not, we check our predicate. If it happens that the messages are passed through, return true. Otherwise, we call spin all or spin some. Now is the question, what timeout value we should pick for such situation. Is this 100 millisecond enough? We should do more or not wait that much because our test will be too long. But for now, let's just go arbitrary for 100 milliseconds. For model CPU, it's already an eternity, so it should work. Once we have that helper function, let's actually use it. We give it an executor. Let's say give it some ridiculously big timeout value, which is 1 second, and a predicate, which will check. Yeah, what we want to check. We want to return that the helper node last TF messages. It's not empty. I think this is the moment where we'll receive the messages. And let's store the value here. Now we can check that. If we received, then there was no timeout. Now let's check how many of them we received. So there should be just one. And lastly, the computation value. So the last published TF message should be 1.5. Yeah, let's try to build it. So syntactically, our test is correct. What will happen if we run it? Middlewise example test. Okay, this failed. Do you think we have an error in the test procedure somewhere? Or maybe we can just try to run it once again. Oh, it's failing and failing again. Something is missing. Maybe the spinning is wrong. Okay, well, what is that? We have a problem in the line 85. So actually what happened is the subscriber did publish the TF message. So it means the second message was correctly passed. But what about the first one? I would expect that we have this value, but we have value 1, so if that message from IMU was actually received, but this one not, well, so this is weird, and it happens all over again. Well, yeah, this is exactly the challenge that we have here. We just called publish 2 times. And what I would expect is that if we first publish this message and then we publish that message and wait for the output, the order of execution would be preserved, but something is wrong in here. And actually, we could probably fix that one way or another, try using different spinning techniques, maybe spin all with some timeout. Maybe we could add additional thread for the execution and try to synchronize this in the test. But we are getting more and more complex unit tests, which you have to maintain some time ago. So after a couple of weeks, when you go back to this test, it will be very hard to read and reason about. So I think this is the time to try to rewrite this test, but using a different approach. And here comes the introduction to our testing framework that we have recently published on GitHub. So please, let's go back to the presentation for now. Yeah, introducing the artist, our brand new unit testing framework that we believe it's a kind of remedy for such problems that we just faced implementing this relatively simple unit test with just 2 subscriptions. What we actually did with this framework, we get rid of the complexity and the message flow path through all the ROS2 layers, and instead of that, we added a thin layer on top of RCL CPP, which introduces that this is a framework for C++ implementations. And instead of doing a real inter-process communication and running the executors and considering any execution model, we just simply intercept certain events from the ROS2 node implementations, like publishing messages or timers firing. We inject directly the messages to the subscriptions. All this is done as a pure C++ function calls. So there is no transport mechanism involved and middleware especially. In addition to that, we also take care of the time source. We can simulate the time flow to single nanoseconds or whatever is the precision of the ROS timer on your platform. So, like I mentioned, it's a testing framework. It's for C++ implementations. We think it is easy to use. What matters is that it gives you a way to write robust and repeatable tests. It is fast. From our last integration in our customer code, it showed that it was almost 10 times faster than the traditional middleware-based tests. It requires no production code changes, as one could be tempted to either dig into the private members of the node or add some adapters on top of ROS entities like publishers or subscriptions just to do the interposition. But that requires changes in the production code. And once you test it, it's no longer the production code that you are testing. So it's not a true validation, right? Yeah, and because we require no node code changes or tricks, we can achieve 100% code coverage, which is important for safety critical applications, for example. Okay, not it. Yeah, let's maybe now switch back to VS Code and try to do an example, but this time using our test. Yeah, let's switch our CMake target to the artist based. And yeah, let's go. Like before, we need to instantiate our node under test. That's obvious. And here comes the difference. We no longer need any helper types or helper functions to interact with the node. This is where the artist framework comes in, and it works like that. If you want to check whether the node have created a odometry subscription, we can use the rtest find. I'll just copy it, find subscription. We can also not only check the topic that it used to be subscribed on, but also the type. So it will be float, and then we give it the node which shall have created such subscription, and lastly, the topic. This function will give you a smart pointer, which is valid when and only when the node has actually did its job and created this subscription. So we can use an assertion to make sure it is valid, because next we're going to use that smart pointer, this object behind it. So this is how we check whether the subscription is created. And by analogy, we are going to do the same for the IMU subscription, and also for the publisher. There's no big difference. Same scheme, but different function. We just find the publisher of this node. And now what? If you remember, previously we weren't quite able to test that the message that arrived on the subscription that was not triggering any side effect we are not really able to test that nothing has happened. And here we actually do. We can do that. We can use the Google mocking framework capabilities for that, using expect calls, and explicitly say that a call from the publisher with which whatever data doesn't happen. So this is the first check. We actually check that nothing happens here. It might be important to do so. And once we set the expectations, we simply feed the message directly to the subscription. It's a simple C++ call. There's no IPC behind the scenes. And you can be absolutely sure that your callback will be executed. You can even use your debugger to jump into the execution directly from this test in the same thread. So that is one check. Let's see if we can build it and run. Okay, builds at least. And so far so good. We just checked that nothing has happened. Now the other part. Because we are using Google mocking, so the procedure is quite inverse. We first set the expectation, we check, and then we do act and trigger something. So we need an expected transformation message. For Google mock, it will be a mean value of 1.0 and 2.0. Then we set up the expectation that the DF publisher will publish exactly that message once. And lastly, we trigger the execution just by injecting the message directly into the subscription. And that's it. Now we should be able to check whether this happens. Right. Okay. Yeah. So what you can tell about this test, first of all, I think we managed to implement it in like 20 lines. So it's easy. You can see it on a single screen, even with such a ridiculously large font. So I think this is one good thing. For the middleware, we used like 70 lines for that. The test was not really doing its job well. And we can even check the robustness of this test. And for that, we can simulate some heavy loaded CI server like Jenkins server. So simulating a stress-free CPU and running the test. Even, I think it was, just repeat. we can repeat it hundreds of times and it will always give the same result. Well, we should actually check, do some, I don't know, just an example to check that the test is failing, but failing also in a repeatable way. Let's make it build faster without the stress test. Okay, let's run the stress in the background, and it fails all the time, every single time. So there's no uncertainty that your test is not checking and verifying your implementation. Yeah, so I think this is the this is it. This is how we use our testing framework. Leave your comments. What do you think about it? I think it's, well, there is a certain amount of investment required to integrate this test to your code base, which is, I think it's neglectable. It's very tiny. You just need to make sure that you build your sources with our test framework. It's a package that you can simply clone from the GitHub repository, build together with your code base, or just install as a package. And then you can write streamlined, simple tests, use it for a code base, and have a peace of mind that whenever they run, they do the job. So I think that's a good selling point. Yeah, that's it. I think we can share the link to our GitHub repository from the presentation. So, like I mentioned, it's an open source project. We host it on GitHub. So, while we are already quite proud of the state, the current development state, we still need your help. Any contribution, any patches, or even feedback from the user is more than welcome. We really want to know what do you think about this tool. And in the meantime, we are also preparing some decent documentation to make it easier to start it, where you can find some tutorials and how-tos to quickly jump in and start using it. So yeah, and I think that's not all. We also need people here at Spirosoft. So I also encourage you to check out our open positions. You will find the link as a QR code right here on the presentation.
I am struggling in this right moment to put the links on LinkedIn. I don't know why it's not working, but we do have a question from the audience. So while I'm trying to post the link to the GitHub, can you see the question from Magda? I will also put it on the screen for everybody to be able to read it. Can you see it, or do you want me to read it out to you?
I can see it. Yeah, okay. Let's just write and try to understand the question first. So we have one more. If we have more than one node, can we differentiate which node was able to successfully create a publisher? Yes. The answer is virtually yes. We can go back to the code for that. So I can show how we do that. All right, perfect. So define subscription takes the parameter, and we check exactly that node that we pass it as a parameter, and we do not check other nodes here. So if we had a second node like node 2, well, that's also a valid test scenario. That sometimes we want to check whether there are no duplicated publishers. It's a common problem with ROS 2 implementation, as far as I get. It can make the systems a bit tricky to debug. They start to behave in a weird manner, and often the problem is that two nodes are creating more the same publisher on the same topic. Okay, and for that, using this this test, we can directly check the node that we are interested in. So it's not an integration level checking; it's a unit test, so that we focus on a single class, on a single implementation. Yeah, but this question is open. I think we can start a discussion on our GitHub page, open an issue or open a discussion, and think about maybe we can extend our test and our existing tool base, and that's add such a convenient way to checking whether there are more publishers on the same topic. That would be nice, I think.
Awesome. Magda said, okay, see, thanks. So I am taking that as we answered the question. And by we, I mean you.
Yeah.
Let's give it a couple more seconds to see if there are any other questions from the audience. And letting you know that we